Hi everyone, this is Srimitra, Siddharth Institute of Science and Technology, Puttur. Now, in this video lecture, I want to tell you the topic of mathematics, that is mean value theorems. Now, I will start with the introduction. In this introduction, we have two basic definitions are there. That is continuous function and variable function. Let us do. Let y equal to f(x) be a function continuous in the closed interval. This means that if a less than or equal to b, c less than or equal to b, then limit extends to c f of x equal to f of c. And for derivable function, let y equal to f of x be a differentiable function in the closed interval a comma b. Then the derivative of f of x at x equal to c exists. This means that limit exists for the function f of x minus f of c by x minus c when x approaches to c. That is, limit extends to c, f of x minus f of c by x minus c exists. By using these two definitions, we can define the mean value theorems like Rolle's theorem and Lagrange's mean value theorems. The first one is Rolle's theorem. Let us start with the statement. Let f of x be a function from closed interval AB to R, that is, domain is closed interval AB and codomain is set of all real numbers R. If the function satisfies the continuous function in the closed interval, and the second point is indeed derivable on the open interval AB, and the third one is f of a equal to f of b. Then, if these three conditions are satisfied by a function f of x, then there is a point C in the interval of open interval AB such that f dash of c equal to 0. So if any function satisfies all these three conditions, then in the open interval AB there is a point C such that f dash of c equal to 0. This is a statement of Rolle's theorem. For example, if you take the function trigonometric function sin x, so f of x equal to sin x, the closed interval is AP. So sin x is defined on the closed interval AP 0 comma pi. Already we know that sin x is always continuous function and variable function on the set of all real numbers. So it is continuous function on closed interval 0 comma pi and variable on open interval 0 comma pi. And also sin of 0 is 0, sin of pi is also 0. So sin 0 0, sin pi 0 means f of a equal to f of b. So that the function sin x satisfies the three conditions of Rolle's theorem. So there is a point C such that f dash of c equal to 0 in the open interval 0 comma pi. So f dash of c means here different derivative of sin x is cos x, that is cos c equal to 0. So that there is a c value pi by 2. So there is pi by 2 belongs to open to 0 comma pi such that f dash of c equal to 0. And another example for this one is tan x. We have that tan x is discontinuous function on this interval 0 comma pi. At the pi by 2, it is discontinuous function. So it does not satisfy the conditions of Rolle's theorem, all the three conditions. So the first condition does not satisfy. So the Rolle's theorem is not applied for the function tan x. And the second mean value theorem is Lagrange's mean value theorem. It is like the statement is also like that Rolle's theorem. This is the statement that let f of x be a function. It is also the domain is closed interval AB and the codomain is the set of all real numbers R. The first condition is it is continuous function in the closed interval AB. And the second condition is the derivable function in the open interval AB. If these two conditions are satisfied, then there is a point C in the open interval AB such that f dash of C is f of b minus f of a by b minus a. So it is Lagrange's theorem. For example, if we take a polynomial that is x cubed minus x squared minus 5x plus 3, the interval is closed to 0 comma 4. We have that some basic functions are there, like two trigonometric functions, sin x, cos x, exponential function, e power x, and a polynomial, every polynomial. All these four functions are continuous functions and derivable functions on the set of all real numbers R. So that here the polynomial is a continuous function and a derivable function on the interval 0, 4. So it is continuous on closed interval 0, 4 and also derivable on open interval 0, 4. So that this function satisfies the two conditions of Lagrange's mean value theorem. Now by Lagrange's theorem, there is a point C in between 0 and 4 such that f dash of C equal to f of b minus f of a by b minus a. Here a, b are 0, 4 and we have to find the C value. F dash of C here is 3c square minus 2c minus 5. This is equal to f of b minus f of a, that is f of 4 minus f of 0 by 4 minus 0. If you simplify that one, we get the value of C is 1 plus root of 37 by 3. It is clearly belongs to open 0, 4. So it is the example for Lagrange's mean value theorem. By observing these two mean value theorems, if in Lagrange's mean value theorem, if there is f of b value is equal to f of a value, that is the initial point and final point are equal, then it converts to Rolle's mean value theorem. So f of b equal to f of a, then it is very clear that in this value becomes 0. So that means f dash of c is 0 here. So in this Lagrange's mean value theorem, if f of b and f of a are equal, then this Lagrange's mean value theorem becomes Rolle's mean value theorem. So that means we can say that the Rolle's theorem, if any function satisfies Rolle's theorem, applied Rolle's theorem, then that function is automatically applied for the Lagrange's mean value theorem also. So any function which is applicable for Rolle's theorem is also applicable to Lagrange's mean value theorem. It is the mean value theorems, basic mean value theorems, that is Rolle's theorem and Lagrange's mean value theorem. There is another generalized mean value theorems, that Taylor's theorem and Maclaurin's theorem. It is extension of these theorems, that is, if any function f closed a b to r is such that f nth derivative is continuous on closed interval a b and f n minus 1 the derivative is derivable on open interval a b, then there is a point p such that there is a positive integer such that and c belongs to a b, then f of b equal to, this is the series, is called Taylor's series, f of b equal to f of a plus b minus a by 1 factorial f dash of a plus b minus a whole square by 2 factorial f double dash of a plus and so on, plus n minus 1 derivative of a into b minus 1 for n minus 1 by n minus 1 factorial plus rn. Here rn is called the remainder. The remainder is b minus a whole power p to b minus a whole power n minus p into f nth derivative of c by n minus 1 factorial into p. This remainder is called Skolmich-Roche's form of remainder. And like this, the another one is Maclaurin's theorem. Maclaurin's theorem is a particular, we can say that this Maclaurin's theorem is particular case of Taylor's theorem. It is like Taylor's theorem because if this function f maps 0 to x to r, x to r is such that is here domain is 0, x and codomain is r. In the Taylor's theorem, AB is the domain, and here in the place of A it is 0, and in the place of B it is x. The same conditions are there. F n minus derivative is continuous and closed to 0, x, and it is derivable on open interval A comma B. Then there is P belongs to Z plus and theta belongs to 0, 1 such that f of x equal to f of 0 plus x by 1 factor f dash of 0 plus x square by 2 factor f double dash of 0 plus and so on plus x power n minus 1 by n minus 1 factorial f n minus 1 derivative of 0 plus rn. Here also the rn is Skolmich-Roche's form of remainder, that is x power n 1 minus theta whole power n minus p f nth derivative of theta x by n minus 1 factorial into p. So this is Maclaurin's theorem and it is Taylor's theorem. For example, by the example for Taylor's theorem, we have the expansion of sine 2x the power of x minus 4. Here we take the value in the place of a is pi by 4. In this is the form to write the expansion. That is expansion pi by 4 it can be written as t. So sine 2x equal to sine of 2 into pi by 4 plus t. That is cos 2t. So we can directly substitute in the theorem. Beam f of b equal to f of a. Here a equal to pi by 4 and b is f of x. So by substituting all these values, we get the form for sine 2x is 1 minus 2 square by 2 factor x minus pi by 4 whole square plus 2 power 4 by 4 factorial x minus pi by 4 whole power 4 plus and so on. It is the series for Taylor series for sine 2x. And another example for Maclaurin series is like if we take the function e power x. It is fixed value for b is 0. So f of 0, f dash of 0, f double dash of 0 all are equal to 1. So in the Maclaurin series expansion, we can directly substitute in the series f of x equal to f of 0 plus x by 1 factor f dash of 0 plus and so on. So e power x equal to, we get the expansion as 1 plus x by 1 factorial plus x square by 2 factorial plus and so on plus the generalized nth term is x power n by n factorial plus and so on. So this is the mean value theorems and generalized mean value theorems, Rolle's and Lagrange mean value theorems, and the generalized mean value theorems are Taylor's theorem and Maclaurin's theorem. Thank you very much.